We'll proceed in vector algebra and calculus. Vector algebra and calculus. Vector is considered as the complete thing in mathematics. Complete thing in the mathematics in the sense whatever we have in mathematics, if we add direction to it, then it becomes a vector. If someone has numerical, if we add direction to it, it becomes a vector. How to add direction to it? That is vector technology. How to add direction to it? That is vector technology. What is vector technology? Vector technology is set of orthogonal components: y-axis, j-axis, k-axis. Okay, or in normal direction: east, north, west, and south, and then up. That is k-axis. East is I-axis, west is minus I-axis, north is j-axis, and then south is minus j-axis. Okay, so that is vector technology. Everything has to be presented in addition of orthogonal components, and subtraction not required. Only addition of orthogonal components. If you make addition of orthogonal components, that is the way someone has to represent anything in direction. Okay, so if someone is saying that someone is moving in northeast, exactly in the northeast, then it's I vector east. If someone is moving exactly in the northeast, if this is north and this is east, then exactly 45 degree from the east, then it is called that the eastward. If I take its component in the east direction, and if I take its component in north direction, northeast, north direction, then it both components are same. That's why he is going in northeast direction. Then if it is I and it is j, then it is I plus j. Okay, that is vector. What is its components? Components share. What is its kind of its essence? Okay, its presence along the component, along the orthogonal component. What is its component along the orthogonal axis? Just add it. That is the vector representation. There is nothing called northeast. There is nothing called I and J. He is moving in I and J. No. Wherever he is moving, what is its component along the x-axis? What is its component along y-axis? Okay. Where he is going? He is going in northeast direction, but double. He is going double in north and single in east direction. You mean to say 60 degree from the east and 30 degree from the north? Yes. Then what is the vector component is? If this is I east and this is north, then from here 30 degree, sorry, 60 degree, more toward north, here 30 degree. What is the vector equation? What is its component along the eastward? What is its component along eastward? Consider this vector is vector in any vector v, then v cos theta. What is v cos theta and what is v sin theta? Those are the components. Okay, so if I consider this as a kind of any vector v, then v cos 60 degree, cos 60 degree is the x component, and v sin 60 degree is the y component. Whatever it comes, just say, or someone can say v cos theta I plus v sin theta j. Okay, or if someone wants in kind of in unit vector, then it will come as v cos square theta plus v sin square theta square root of v. That will be v1. So sin theta, so cos theta I plus sin theta j, that is the vector in which that is going. If it is 45 degree, then it will be 1 by square root of 2i plus 1 by square root of 2j, because I know sine and cos of 45 degree. Anyway, this is vector technology. Vector technology means first you get the component along the orthogonal axes and just add it. That is vector technology. So more towards we saw, if I want work done, If I want work done, what is the work done? We took example of a wind. Consider that if I am standing here, there is a wind, it is going, there is a direction that is, consider this is eastward. I mean, it is really eastward, okay? This is eastward, and this is northward, and this is sky. Okay, wind is blowing in somewhere. Okay, so wind is blowing somewhere in some direction. Okay, if that is the case, then I always take example of a car. So a car, from, consider it is at origin. This is origin, this is eastward. This is origin, this is northward. This is origin, this is sky. Now, now a car is moving from 0 to x along eastward. Okay, wind is blowing in a direction called I plus j. Direction, if I say that it is only the direction, that I plus j by square root of 2. What is the power of the wind? That is square root of 2. Okay, then if the power of the wind is the square root of 2 and direction of the wind, that is unit vector, is I plus j by divided by square root of 2, then someone can say that wind is I plus j, because direction and its magnitude, power, if I combine together, we can combine it. It's possible. That is I plus j. If car is moving along eastward, that is I vector, from 0 to x, then how much energy it is receiving from the wind? That is question mark. So the wind vector dot product with the displacement vector is the work done by the wind on the car, or car is receiving, work done means energy. Work done means energy. That is called work done. So whatever the work done by the wind on the car is the energy car is receiving from the wind. Okay. If car moves 0 to x, okay, and the net work done by the car, net work done by the car is is consider it is 100, and work done by the wind on the car moving 0 to x is 50, then 50 energy came from the fuel. If there is no wind, then full 100 energy will come from the fuel. If the energy from wind is 100, then no energy burnt from the fuel. That is, means if car is moving from one location to other location and energy it is spent, car is spending energy, right? Car spent 100 joule of energy, and then someone calculated the wind 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 force vector dot with the displacement vector, and he saw it is 100, means car did not burn any fuel, means full energy it received from the wind. But energy can be negative also. In that sense, wind was opposing the car. In that way, the fuel burning was more. If wind is opposing the car, in a sense, minus 50, and then the fuel burning was 150 joule, minus 50, 100. Okay, that way. Now we proceeded in this energy calculation, and we saw that if the wind that is blowing, that is not a numerical vector, that is algebraic vector. Wind is xi plus yj, instead of I plus j, it is xi plus yj. If wind is xi plus yj, then force dot displacement vector is the work done. When force vector dot displacement vector, force vector is a function over x and y, the variable, algebraic variable, then multiplication is not normal multiplication. Multiplication becomes calculus multiplication or calculus integration. In that sense, we have to find calculus integration means there will be one limit, there will be one integrand, and there will be one differential. This is the grammar of integral calculus. Grammar of vector is there will be I vector, there will be j vector, there will be k vector, or whatever orthogonal components are there. Now, the vectors, the I component, j component, k component, and others, and then you add it. That is the terminology of vector. This is the only terminology of the vector. This is the only terminology of integral calculus. Limit, that is the independent components limit, and then dependent component as integrand, and independent component as differential. This is the grammar of integral calculus. If that is the case, then here the independent component is x-axis and dependent component is force. Because okay, so in that sense, force dot displacement vector. Then please watch our previous video. So if we want in term of calculus, then it comes as force vector dot d of position vector. It resolves in a way that it becomes force dot displacement vector somehow with integral calculus. Altogether, someone mixes it, the work done or energy transferred by the wind, then it becomes force vector dot d of position vector in the direction where the car is moving. So if car is moving along x-axis, then position vector at any point along x-axis is xi plus yj. If I take any point on x-axis, that is x comma y. Xi plus yj, if I draw a position vector from the origin, y is 0, xi, then force vector dot d of xi, force vector is xi plus yj, then it becomes x dx. X dx 0 to x square by 2 is the energy that car is receiving when the wind force is capital F. I don't trust you. I don't trust you, someone would say. I don't trust you in a sense that I trust only numerical. Consider the wind is moving in I plus j direction and car is also moving in I plus j direction. Then work done in I plus j, square root of 2 is the wind. Square root of 2 is the wind magnitude. And displacement is I plus j means 0 to 1 comma 1 is the displacement. If that is the case, then again magnitude is square root of 2. Since they are in same direction, work done is 2. Now show me through integral calculus, the work done is 2. Okay, I will show. Now force vector dot d of position vector 0 to x. So x, if car is moving in I plus j direction, it is origin, and I plus j direction, this I plus j means point is 1 comma 1. Along x it is 0 to 1. Integration x is 0 to 1. Force is I plus j dot d of position vector. Along this line, if I take any point here x comma y, then dxi plus yj, d of xi plus yj. The integration is 0 to 1, I plus j, d of xi plus yj. That becomes I dot dxi plus j dot dyj. It becomes x dx plus y dy. X dx plus, now show me how it is 2. X dx plus y dy. X dx plus y dy. Okay, if I talk about vector I plus j, how it can be represented in a line? That is represented in a line is y equal to x. I plus j is 45 degree from the x-axis. That is y equal to x. Whatever is x is same is the y. 45 degree. Y equal to x. If that is the case, then it becomes x dx plus y dy becomes x dx again. 2x dx. I'm sorry. I'm sorry. Okay, it was force was I plus j, and this dot d of position vector dxi plus yj. If someone does it, it becomes dx plus dy, not x dx plus y dy. Dx plus dy. Y is equal to x. It becomes dx plus dx. 2 dx. 2 I can keep outside. Integration of dx is x. 0 to 1 means 1. 2 again. So it can be said that whatever the energy calculation we do with the force dot displacement vector is a special case of this integral calculus, that x limit is 0 to x or whatever it is. Integrand is the force dot d of position vector. Okay, someone can think now, if someone say, if consider the force vector is I plus j, force vector is I plus j, where a displacement is happening in a circular fashion. Okay, I said displacement is happening in I same direction, right? Now displacement is happening in a circular fashion. This is centered at the origin. The center of the circle is origin 0 comma 0. Now a car is moving from here to here. As I always say, this is y-axis, this is x-axis. Means car is moving on the ground only. I just rotated it. So there is no Since Earth gravitational pull is at 90 degree, Earth gravitational force will not work here. As far as car is moving like this. So car is moving like this, then 0 to A. Car is moving x-axis 0 to A. In that case, what is the work done? From the wind that is going in I plus j. I plus j dot d of position vector. Your position vector is always xi plus yj. Take any point here x comma y. Always you say it is x comma y, then it becomes d of xi plus yj. Force vector is I plus j from 0 to a. X is 0 to a. I plus j dot d of xi plus yj. Again it becomes dx plus dy only. It was along the line, again it was dx plus dy. It is around the circle, again it is dx plus dy. Everywhere you are dx plus dy, dx plus dy. Okay, just hold on. Y is different. There y was equal to x when it was along the straight line. Here if it is a circular, then x square plus y square equal to a square is the formula of circle. Y equal to square root of a square minus x square. Y equal to square root of a square minus x square. If that is the case, then dy equal to minus xy square root of a square minus x square dx. Now we have to integrate dx plus minus xy square root of a square minus x square dx. Dx, if I take it common, then it becomes, okay, it becomes square root of a square minus x square minus x divided by square root of a square minus x square dx, 0 to x. If someone has caliber, someone can integrate, and this is what is the work done down the surface path. So y is different. So abstract. If okay, let's proceed. Consider the force vector is F1i plus F2j. We took example of force vector at xi plus yj. Force vector at xi plus yj. Okay, consider the force vector is F1i plus F2j, where F1 is a function over x and y. Here if I say xi, then F1 is xi plus F2. Everything is in capital. Capital F, that is the force vector, equal to F1i plus F2j. F1 is the function over x and y, and F2 is function over x and y. So it becomes F1i plus F2j. It can be yi plus xj. I said xi plus yj. It can be yi plus xj. It can be y sin x plus x cos x, y sin x I plus x cos x j. Okay, anything. Function over x and y, F1 and F2. If I take the net energy that is transferred by the force vector along any displacement vector whose position vector is xi plus yj, then the net energy transferred by the force vector is integration from 0 to x along the x-axis, whatever is the limit, 0 to a, 0 to 1, 0 to x. Force vector is F1i plus F2j dot d of position vector, that is always generic, that is xi plus yj. If that is the case, then it gets resolved into F1 dx plus F2 dy. So energy transferred by the force vector is always integration from 0 to whatever along the x-axis, F1 dx plus F2 dy. Always fixed. Always fixed. If it is generic, can someone think more on it? Consider that F1 dx plus F2 dy. Consider Consider there is one algebraic function called small f. Consider what is algebraic function? Algebraic function is y sin x plus cos x plus x to the power 3. This is the algebraic function. Consider any algebraic function small f. Consider any algebraic function small f whose partial derivative along x-axis is f1. Possible, right? Which partial derivative along y-axis is f2. I mean, if there is a function called small, consider there is a function called g. This is better. Consider there is a function called g. dg by dx equal to f1. dg by dy equal to f2. Consider like that. Then it resolves in, now our the net energy calculation was f1 dx plus f2 dy. f1 is dg by dx and that is dg by dy, f2. Then someone resolves it, it becomes g1. dx gone, dy gone, it becomes g1. If it becomes g, then we got the integration, right? Someone would say g plus g. Okay, it is g only. So someone gets it. Someone say, oh, I got it. If there is a function, if there is an algebraic function g for which dg by dx is f1, for which dg by dy is f2, then if you replace, but the net energy calculation is f1 dx plus f2 dy, f1 is dg by dx, it becomes g1. dg by dx, okay, dg by dx into dx, and there dg by dy is f2, okay, into dy, dy gone, dx gone, it becomes dg1, okay. So something, it is something someone can say, it is more or less, I mean what I'm trying to say, that if I have a function, if I have a function, if I have a function, I believe there will be better understanding on it. Consider I'm trying to calculate integration of fx dx. Consider I'm trying to calculate integration of fx dx. Okay, and it resolves into another algebraic function called gx, fx, function over x, fx dx. If someone integrate it, he gets gx. Okay, then if I know what is gx already, for which dgx by dx is fx, then fx dx can be as a whole replaced by gx. Make sense? fx function over x dx, function over x dx, integration I have to find. If I say fx dx is gx, then directly I can replace fx dx with gx. That is the net integration. Okay, then I have to set the limit. So if I know any function gx for which derivative dgx by dx is fx, then fx dx directly I can replace it with gx. Okay, then I can set the limit. Similarly, I have to find f1 dx plus f2 dy. If I know any function g for which dgx by dg by dx partial derivative is f1, dg by dy partial derivative along y-axis is f2, then I can replace this integration completely as g. Okay, it is multivariate case, completely at g only. Like fx dx in earlier example, fx dx was gx, then dgx by dx was fx. I can replace here. fx is dgx by dx into dx, it resolves into gx back, g back. Okay, the net integration is g only. Similarly, if I go with the multivariable case f1 dx plus f2 dy, capital F, now f1 is dg by dx, I can put there dg by dx into dx. Okay, f2 is dg by dy into dy. If I solve it, it becomes g only. The net integration becomes g only. Let's set the limit. This proves that if I know any algebraic function for which partial derivative along x-axis is f1, if I know algebraic equation g for which partial derivative along y-axis is f2, then I know the integration, that is g. f1 dx plus f2 dy, okay, capital F1 dx plus capital F2 dy. What is the integration? Integration is y you have to replace with the x. This is what we saw in the case of line and circle. Okay, where the line equation and circle equation, they have separate y and x relationship. So x dx is all right, but y dy, f1 dx is all right, plus f2 dy, there y, or everywhere y I have to replace with the algebraic equation along which we are trying to calculate the energy computation. But if I know algebraic function g, for which partial derivative along x-axis is f1, partial derivative along y-axis is f2, then I know the integration. I don't need to go with the path at all. What is y equal in term of x? Just replace full with a g and set the limit. Limit is nothing but lower point to higher point along the x-axis, a to b. If that is the case, then I don't have to bother. Then what I need to bother? Two things I need to bother. I have to find one algebraic function for which the partial derivative along x-axis is f1 and partial derivative along y-axis is f2. If I find any g in the world somehow, then I know the integration. If I know the integration, the set the lower limit and higher limit, you get the energy. Then what I am missing here? You don't need y and x relationship. You don't need the path. Like if it was circle, then y was the square root of a square minus x square. It was a straight line, then it was y equal to x. It was y equal to x that I need to set here, not required. Okay, then someone has to find the algebraic equation g which satisfy dg by dx is f1, dg by dy is f2. Okay, I'll find. Then I don't need this circular path, and only I need the lower limit and higher limit true. But it's not true. It's not true in the sense that for every curve, for every force vector. Now we are dependent upon the force vector f1 and f2, not on the curve. For every force vector, there is no algebraic vector for which partial derivative is f1 and f2. That is the catch here. For everything, it is not possible. But for force vector, for which algebraic equation g is available, for which dg by dx is f1, capital F, that is a force vector, equal to f1i plus f2j. If there is a g algebraic function dg by dx is f1, dg by dy is f2, if I am able to find it, then this force vector is called path independent vector, because then only we need the lower limit and higher limit to get the net energy. Okay, let's see if our force vector xi plus yj is path independent. Xi plus yj is path independent. That's fine. If that is the case, how I can find an algebraic equation for which the dg by dx is x and dg by dy is y? Then it is path independent, and just get that algebraic function and set limit 0 to or whatever a to b, you get the energy. Okay, consider there is a function called x square by 2 plus y square by 2, algebraic function, that is g equal to x square by 2 plus y square by 2. If that is the case, then dg by dx is x, dg by dy is y. If I talk in gradient vector, it becomes xi plus yj, or f1 is x, f2 is y. This is what we want. So f1 dx plus f2 dy is the net energy calculation. Now if I want through circle, if I want through line, if I want to dash, we want to not require, because I know the result, that is x square by 2 plus y square by 2. So path is not required. Y to x relationship or line equation or curve equation is not required. I know integration is x square by 2 plus y square by 2. Just set the limit. Can you prove it that just setting the limit will give the energy? Yes, I'll prove it. Okay, let's prove it. Okay, now consider this is x-axis and this is y-axis. Okay, this is x-axis and this is y-axis. If that is the case, there is a line like this that intercept here at 3, 0 and intercept the y-axis at 0, 3. There is a line that intercept y at 0, 3 and it intercept x at 3, 0. If that is the line, then what is the work done? Okay, the work done, the way we are talking here, the work done is x square plus y, x square by 2 plus y square by 2, limit is 0 to 3. I'm sorry, if it is x square by 2 plus y square by 2, lower limit to higher limit. Lower limit to higher limit. Now what is lower limit? Now lower limit, if I talk about the line, we are calculating the work done along, if car is moving along this line, what is the work done by the energy, that is xi plus yj. Okay, now lower limit is in x and y. If it is x, then it is 0 to 3. If it is x and y, the lower limit is 0, comma 3 and higher limit is 3, comma 0. We are trying to calculate work done by a wind, that is xi plus yj, along a direction on a line that is y plus x equal to 3, or along a line that connects the point 0, comma 3, that is intercept on y-axis, and 3, comma 0, that is x-axis. If someone draws a line, what is the work done of this wind force? Then that work done is, we are saying F1, that is xi plus yj is the wind force. F1 dx plus F2 dy, x dx plus y dy. But as per our fundamental, if I know any algebraic equation for which dg by dx is x and dg by dy is y, then simply get the g and set the limit. We got it. Let it x square by 2 and plus y square by 2. Set the limit. Lower limit is 0, comma 3 and higher limit is 3, comma 0. If it is 0, comma 3, then and higher limit is 3, comma 0. First set higher limit, then it becomes 3 square by 2 and minus, then lower limit is 0, again 3 square by 2. Net work done by the wind is 0. Now this is along anything you take from this point to this point. Okay, if you say anything from this point to this point is from 0, comma 3 to 3, comma 0, it will always be 0, guaranteed, because we calculated it from the begin point to end point. If that is the case, then let's try with the professional way, not through this way. Professional way is x dx plus y dy, where the equation of the line is y plus x equal to 3 minus x. Okay, then y is 3 minus x and dy is d of 3 minus x minus dx. Okay, then it becomes x dx into 3 minus x d minus x. It becomes x dx plus minus 3 dx plus x dx. Okay, then it becomes 2x dx. Okay, 2x dx, I am also checking, 2x dx minus 3 dx, 2x dx minus 3 dx. Okay, then it 2x dx minus 3 dx. 2x dx is 2x square by 2, x square. X square minus 3x is the net work done. Limit is 0 to 3 because it is only x. So x square minus 3x, 0 to 3. If I set 3, then it will become 0. 0, 0. Okay, understood. Now try with the circular line. Now 0 to 3, where y equal to square root of a square minus x square. Okay, square root of a square minus x square. Okay, if that is the case, then I believe someone has to try. Then it is x dx plus y dy. Y is square root of a square minus x square, and dy, y is square root of a square minus x square. Dy is dy by dx into dx. Then it becomes minus x by square root of a square minus x square dx, gone, minus x. X dx minus x dx, anyway it is 0 only, because x plus y vector is radial vector. So it is always perpendicular to the curve and it is 0. So rather than going through so many path, if my force vector is xi plus yj, then I can say that work done from point 0, 0, comma 3 to 3, comma 0, okay, whatever, it is always 0. Independent of this is called path independent vector. If you are true, then what about xi plus yi plus xj? Yi plus xj. Can you find any algebraic equation for which partial derivative along x-axis is y and partial derivative along y-axis is x, yi plus xj? If you are able to find it, just set the limit, lower limit and higher limit, and you get the energy transfer. Okay, if that is true, then what is the better way to find it? If I have if I have F1 dx plus F2 dy, that is the net energy, then integrate F1 with dx. Here F1 is y dx, that become yx. So G, the algebraic equation what we are thinking about the result, dg by dx equal to F1, dg by dy equal to F2. If that is the case, then G equal to F1 dx, G equal to F2 dy, G equal to F1 dx, then it becomes xy. Xy plus any function over y only. Then only dg by dx is y plus 0. This is what we want. So dg by dx is F1, that is y, then G equal to y into x plus any function of y only. So that dg by dx, that will be gone, it becomes y. If that is the case, dg by dx, then g equal to xy plus any function over y. If that is the case, then if I differentiate it with by y, then it becomes x plus differentiation of any function of y. That that is nothing but f2. So x plus any differentiation of any function over y equal to f2. F2 is x, x gone. Differentiation of any function over y equal to 1. Then the function over y is y. I believe so. It is y. If that is, it is y. I believe it is all right. I don't know. So if that is the case, then the g what we are expecting, is xy plus y. If that is the case, then is dg by dx is y. dg by dy is x plus 1. dg by dy, no, that is not we want. Okay, okay, how we proceeded, dg by dg, let's consider dg by dx is y, dg by dx is y, then g equal to integration of y with dx, yx plus c, consider any function c of y. Okay, so g equal to x into y plus c of y, dg by dy equal to x plus c dot y, that is difference or dc by dy, x plus dc by dy equal to f2. F2 is x, so x and x is 0. Okay, x, if it goes that side, it becomes 0, not 1. So that is a mistake I did, 0. If that is the case, then dc by dy equal to 0. dc by dy equal to 0. It is not possible. dc by dy equal to 0, if I say, then it is something very vague. dc by dy equal to 0 means it is undefined. This proves that the xi plus yj, sorry, yx plus xj, there is no kind of, if I say, okay, xy plus xy, there is no algebraic function that is available for which the partial derivative along x-axis is y and partial derivative along y-axis is x. Not possible. If that is the case, then integrate the work done, energy transferred on a car that is moving in a straight line and curve. Both are different if I take same point 0 to 3. Okay, someone can calculate it. We will proceed on this energy. Actually, I had brought an earth. Okay, I had brought an earth, and the idea was to prove that earth, what is the gravitational force of the earth on any mass. If there is a mass, okay, if there is a mass that is dropping on the earth, this mass has mass of m kg. Then what is the gravitational pull? As per the physics science, the gravitational force is minus g. G is the gravitational acceleration. Minus g into m. R vector divided by r to the power 3 is the gravitational pull, gravitational force. gravitational force equal to minus because it is attracting, plus means it is repelling. Okay, matter of direction only. Minus g m into r vector. R vector, if it from anywhere, it will be attracted in radial fashion only. If there is a circle, and circle if I keep, it will be attracted in radial fashion only. So minus this radius vector, minus g into m radius vector, r vector divided by r to the power 3, whatever the distance is, r to the power 3, it is inversely proportional to the distance. If distance is less, then gravitational pull will be more. Distance is far, gravitational pull will be less. In that sense, now prove this force is path independent. Means try to get one algebraic equation. Try to get one algebraic equation. It can be considered as an assignment to this tutorial. Try to get one algebraic equation for which that algebraic equation is G, for which dg by here r vector, if I see r vector is nothing but xi plus yj plus zk. R vector means nothing but xi plus yj plus zk. If this is force vector, capital F is the force vector, then net work done is F1 dx plus F2 dy plus F3 dz, where F1, where capital F, that is the force vector, that is minus gm r vector divided by r to the power 3, should be represented as F1i plus F2j plus F3k. If I know any algebraic equation G, for dg by dx is F1, dg by dy is F2, dg by dz is F3. If that is the case, then F1i, then it becomes, someone has to find any G for which dg by dx is F1. What is F1? Minus gm r vector. R vector is xi plus yj plus zk. Okay, divided by r to the power 3, then it is a square root of distance, that is x square plus y square plus z square to the power 3 by 2. So I can say that the F1 is minus gm, that is constant, x divided by x square plus y square plus z square to the power 3 by 2 I, minus gm yj divided by x square plus y square plus z square to the power 3 by 2, plus minus gm zk divided by square root of, divided by x square plus y square plus z square 3 by 2. Now if that is the case, I have to find one g for which dg by dx is minus gmx divided by x square plus y square plus z square to the power 3 by 2. dg by dy dg by dy is dg by dy is y by x square plus y square plus z square power 3 by 2. dg by dz is z by square x square plus y square. Can someone find G like that? If someone finds G like this, then he cracks it that Earth's gravitational pull is path independent. If that is the case, if I check what is the energy that this receives when it moves from here to here, means what is the energy this Earth loses, means Earth transfers the energy in this object when it moves from here to here. If I just drop it here to here, there is a work done, right? Because nothing moves for free. If this is moving, means someone is working, right? Someone is transferring the energy. Earth is transferring the energy from this location, from location A to B. The Earth releases the energy. That's how it moves. But instead of moving from A to B in a straight line, if I say, instead of moving in a straight line from here to A to B, if it is moving like this, then if I say Earth is releasing same energy, independent of the path, only dependent upon the point A and point B. If it is a straight line, if it is a curve, or it is a slope, or it is a staircase, whatever it is, the energy what Earth is releasing is only dependent upon the begin point and end point. If if someone has to prove it, then someone has to prove that Earth gravitational force, there is a some algebraic vector G for which the all three partial derivative dg by dx, dg by dy, and dg by dz are the all three component of Earth gravitational force. If someone get that G, then he can prove it. This is path independent as per the calculus fundamental. So this can be taken as an assignment. I believe answer is done only. It is very straightforward. I believe so. So the way we proceeded in that says that G equal to F1 dx plus any function of y plus any function of z dg by dx, then you differentiate whatever is received as G plus dz by dy plus c dc by dy plus 0. Then equate it to whatever is f2. dg by dz is now whatever you have got g till now, that that whatever that g by dz plus 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 whatever the cz we are saying dcz by dz equal to whatever there is z. Equate it and get the z g. Or someone can try in polar coordinate system directly, because the gravitational force is minus gmr vector divided by r to the power 3. Directly someone can try in polar coordinate system. If that is the force, if that is the force vector, then g vector dg by dg by dr equal to this in magnitude, because f1 is magnitude and I is the direction. Here it is magnitude and r vector is the direction. Calculate the unit vector along the r direction, get the magnitude, and dg by dr is that magnitude. Very simple, right? Quick. Okay, so this can be matter of assignment, and then we will. So please do support us. +91 is the India country code, 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.